I am Ashish Srivastava, an engineering manager at Google, and your post-lunch designated caffeine substitute. All right? Today, I'm here and very, very excited hosting the first ever gRPC Conf India. And to share what's there in the roadmap for gRPC and what the team has been working for the last year. This includes forward-looking projects and some great features which are there in the existing projects. All right? Let's get started. But before we do that, let's look at the three pillars of our roadmap. The first one, modernization, where we are looking at evolving the core of gRPC to align with what or how the cloud-native applications are built today. This includes area like gRPC transport for MCP, which was right before this if you were here, and gRPC Rust. The second pillar is service mesh and XDS. Since the GA launch in 2020, we have continued to focus on building a word of service mesh without sidecar proxies, right? Think of this as gRPC to work seamlessly in environments where discovery, load balancing, and security is the important piece that you want and is policy driven. Last but not the least, observability. As they say, you can't improve what you can't see, right? This is why we have continued to invest in metrics, logging, and tracing. Together, these three pillars define where gRPC is headed next and how we are building a cloud-aware and insight-driven future for gRPC. First in the list is we are at an intersection point of gRPC and AI ecosystem. For the last year, two protocols have exploded in popularity. The first one, MCP, the Model Context Protocol, and the second one, Agent-to-Agent Protocol. While MCP allows you to export your MCP server and export tools via those MCP server so that LLMs can build or take actions on your behalf, Agent-to-Agent focuses on long-lived agents to talk to each other in a structured and standard way. While now look at me, the interesting part. Agent-to-Agent protocol was built with gRPC as the very base of it, right? So agent-to-agent already supports gRPC. However, since very recently, MCP did not support gRPC. And since then, we have been getting a lot of community requests to add this transport. I'm happy to announce, and as Pawan and Ashish shared just before this talk, we have a fully functional working transport, gRPC transport for MCP. And we are working with the MCP maintainers to make their transport layer pluggable so that the gRPC transport can be the first class family member of the MCP transport family. With this, gRPC isn't just powering the backend systems anymore. It is a core and critical part of your backend AI ecosystem. I can't wait to see what developers do with this and what new services and technology do they build on top of this. The next, let's talk about something that has been requested the most, and it's the most recent addition to gRPC family. We are officially announcing gRPC Rust, built on top of already super popular Tonic implementation. We are working to bring the feature parity from other languages, and also working on implementing a fully functional XDS implementation so that you can run your service mesh natively in Rust. We are working with the Tonic maintainer, Lucia, and to make sure that for existing Tonic users and the new gRPC Rust users, the experience is top-notch from the very beginning. And if you want to dig deeper and understand more, gRPC Rust team is doing a talk, I think around 5 or 4:40 4:55. Do join them to learn more about what's coming next. Next up, let's talk about two major additions to our XDS service, the ext-proc and ext-auth. ext-proc is all about processing. This allows you to modify your incoming request and outgoing responses right there on the server. And ext-auth, as the name suggests, is all about authorization. It decides whether a request should be allowed or not. Both of these features use a plugin model, and they're different than gRPC interceptor model. They use something called callout pattern, where the gRPC server will call a shared ext-proc or auth service and for making the decision, and this gRPC, the external gRPC server, will be pre-configured to decide what to modify in the request and response, or whether this request should be authorized or not. And if you are part of a platform team, this is huge, because now you can implement a unique and standard environment for yourself by just running ext-proc and ext-auth services, and they can be either centrally located or co-located with the gRPC server that you're running. And all you have to do is wire them together with the service mesh. This feature is already close to design completion, and the gRFC will be out for it early next year. Next on the list is HTTP Connect. For those who are unaware, HTTP Connect allows you to create a secure tunnel over HTTP connection. This allows for protocols like SSH, FTP, and many more to go over an HTTP connection, right? This is useful in majorly two scenarios, the forward proxy and reverse proxy. Forward proxy is more about sending an outgoing request to, from a network which is restricted, and reverse proxy is about incoming request to a network which is otherwise isolated. For example, you can use HTTP Connect to connect to a publicly to connect to a server which is publicly hosted on cloud service from an on-prem network, even though those publicly cloud, those servers hosted on public cloud are not accessible publicly in general. gRPC has supported HTTP Connect since 2017, but we are simplifying how we configure it. Instead of manual complex configurations, we are integrating this with XDS so that the management is all dynamic, and the connections and configurations are also dynamic, so that you don't have to configure them manually. This means a seamless, unified, and integrated experience for your cloud and on-prem environment. And I'm happy to announce that C++ and Java already support this as an experiment. All you have to do is change that feature flag, and you would already get this. Still with me? Or the biryani has taken over? All right. If you're there with me, let's talk about SPIFFE trust domains, SPIFFE trust bundles. We are happy to announce that we are adding support for SPIFFE trust bundles as well. For those who might be unaware, SPIFFE assigns cryptographic identities to your workloads. These workloads could be running in Kubernetes, virtual machines, or anywhere else. And using these cryptographic identities, you can configure mutual TLS connections. And folks who have configured mutual TLS connections know how difficult it is and how complex it can get, right? While gRPC has supported SPIFFE-based mutual TLS connections using certificate authority files since 2021, we are now expanding that to include the SPIFFE trust bundle itself. This means you can now manage multiple trust domains, and consider a scenario where you have separate trust domains for testing, staging, and production. This allows or makes sure that your less secure environments like testing and staging don't accidentally access your production environment. This also allows you to configure different identities and domains for your different teams or product areas. And they can still communicate with each other in a seamless fashion. Expect this to roll out in C++ and C++, Go, and Java early next year. Next up is serverless integration for proxyless service mesh. In today's world, Kubernetes and serverless workloads go hand in hand. They are generally, all the architectures in the modern era, they combine these two together to build a service. More and more teams are deploying this hybrid architecture, and that means that naturally both of the sides need to be able to join same side of same service mesh for service discovery, security, and dynamic management. However, it has been easier said than done right now. What's been going on is previously connecting the serverless workload to a service mesh was not simple. You could do it, but it was very complex, required workarounds, and it was not uniform. We are now changing that as well. We are, with a few enhancements to the proxyless service mesh and serverless workloads to make this work seamlessly. The first on the list is we are doing XDS host rewriting. This enables vanity URLs and simplifies endpoint service discovery for serverless workloads. The second one is JOT-based authorization, where you can configure fine-grained, secure RPCs. The third on the list is MTLS with spiffy identities, so that all your workloads can be identified and verified. Together with all these three features, the hybrid architecture and serverless service mesh have become more and more seamless and can connect easily. All right. Who does not like rate limiting? Huh? Now to XDS global rate limiting. Traditionally, how do we run rate limiting? We put a proxy in between somewhere. It could be an API gateway, ingress gateways, or a sidecar. But these implementations have added latencies and incorrect rate limiting. With XDS global rate limiting, the rate limiting logic lives inside your gRPC library itself, working directly with your control plane. This is powered by XDS, Cross Discovery Service, along with rate limiting quota service, which is also known as RLQS. And RLQS has specifically been designed to aggregate the load across your servers and dynamically change the rate limits across the servers and apply them via the globalized control plane. This results in a highly performant, globally coordinated rate limiting and a completely decentralized data plane. The protocols and gRPC library used in these implementations are completely open source. And the first RLQS implementation will be coming to GCP Cloud Service Mesh early next year. Okay, now let's talk about our work with Istio integration. gRPC proxyless experiment support was added with Istio in 2021. This integration has relied upon an Istio agent, which is like a control plane proxy running between your application and your service mesh. However, that connection has not been secure till now, and it also adds additional complexity. We are improving that by removing the need of that proxy completely, simplifying the architecture, and making the integration more direct and robust. In short, fewer moving parts, fewer headaches, and better integration. Next, We find ourselves debugging gRPC very frequently, right? And Channel Z has long been a very powerful tool for that. Consider scenarios where you have a flaking network connection or laggy WAN. Your default go-to is Channel Z to be able to see what's going on in your service. Now, Channel Z V2 takes this to the next level. It's designed to be more flexible and generic. And it also allows you to export more detailed, fine-grained, custom implementation-specific metrics. For example, your transport can have multiple TCP sockets over one sub-channel, right? And with Channel Z V2, you can export that detail and make a better understanding of how is your system performing and what the system is doing. Additionally, Channel Z V2 is built to evolve with gRPC over time. As I said, it's generic, and it is also going to continue to evolve. So whenever you change any gRPC resource or hierarchy, you don't have to go change the protocol for Channel Z V2, and then it will seamlessly continue to work. This means faster, more flexible, and more enriched data for greater debugging and greater flexibility. And the best part, the first implementation of Channel Z V2 is rolling out to C++, again, early next year, because there's nothing left in this year, right? Okay. As now going to observability, as I said initially, you can't improve what you can't see. This is why we have been investing a lot in the metrics side of things. And I'm happy to announce that we have added 12 new metrics, specifically for weighted round-robin load balancing policies, sub-channels, and XDS clients. We are also adding cross-cutting labels that indicate XDS localities. It gives you deeper insight into which cloud zone your workload is running in. But wait, we have more. Along with these 12 new, we are also announcing a framework for non-per-call metrics. Consider components like XDS client, which go through multiple calls and sub-channels, and those metrics will be much more enriched with this per-call metrics. They'll have enriched observability. This non-per-call metrics framework allows you to capture more comprehensive data, making it easier to troubleshoot and optimize the proxyless service mesh. Together, these advancements make running service mesh and gRPC more reliable and insightful than ever. We are done. So quickly recap. We have covered how gRPC is at the core of AI with protocols like MCP, A2A, how we are bringing gRPC Rust and making things much better for people. Rust lovers will be very, very happy. We are doing bunch of changes to features in proxyless service mesh and bunch of additions to observability. All signs that future of gRPC is strong, modern, and wide awake like all of us. To keep exploring, please go visit gRPC.io. Please visit the YouTube channel, and we also host Bangalore-specific meetups. We will, please go there on the link and register for the upcoming one. Thank you for being an amazing audience, and enjoy the rest of the conference.